In the last program, we have seen how to use printf, but we weren't really computing anything. We were just displaying a bunch of text. Now, what if you want to do some computations? How would you set up your code for that? Let's take a simple example. Let's write a program to calculate final velocity of an object. So the final velocity equation is given to you, which is v final equals to v initial plus acceleration times time. So let us start building the code for this. So obviously the first line in your code will be to include the header files. The next line is your main, then start the main block. Now in this problem, we can clearly see that we have four variables: vf, vi, a, and t. In a real world scenario, vf, vi, a, and t can take any value. That is, it can take an integer value or a floating value. For this problem, let's assume that it's only going to take integer values. So the first step is we have to declare the variables. Declaring the variables is nothing but telling the compiler that these are the variables that my code is going to use. And the compiler allocates some memory to store these variables. So to declare the variables, we are going to specify the data type for the variables, which means that the variables can only hold integer values, and then we list out the variables. The first variable is vf, comma vi, comma a, comma t, and terminate it with a semicolon. You can have this in any order. You can first have a, vi, vf, t, that's your choice. But you can declare all the variables in a single line. Of course, you can also declare variables in multiple lines. That's not a problem. You can write int vf, vi, semicolon, int a, int t. So this is perfectly valid, but I just choose to write all the integer variables in a single line. There are instances where I use multiple lines, but this is a simple problem, so everything is in a single line. The next step is we need values for vi, a, and t. So let's assign some values to vi, a, and t. Let's say vi equals to 10, a equals to 5, and t equals to 3, semicolon. So this is the variable declaration part, and this is the variable initialization part. If you try to initialize the variables without declaring them, then the compiler is going to throw errors, and int is a keyword. Now, if you want to declare vf, vi, a, and t as floating point numbers, you replace int with float. So the next step is writing the formula. So the formula given was vf equals vi plus a times t. Typically in programming languages, for the multiplication, you have to use the asterisk. You cannot use the dot operator. So the values of vi, a, and t are plugged in, and then you can do the computation. So the system is going to compute that, and it will store the result in vf. Now the next step is displaying the result. So we can write printf final velocity is equal to %d, comma vf. So if you remember, I said that printf is going to display the text as it is. So when you run this program, it's going to display final velocity is equal to, and as soon as it encounters %d, it's going to go outside and look at the first variable. It finds vf. Vf is copied here. That is, the value of vf is replaced in this location. And of course, then you have return 0 and then close the parentheses. So on the console, it's going to read, or it's going to write, final velocity is equal to %d, so that's VF. Now the computed value of VF was 5 times 3, that is 15, plus 10, 25. You can also add text after %d. So before the double quotes, you can write something like meters per second. So this is going to say 25 meters per second. So it's not that %d has to be just before the double quote. You can write things after %d as well.